So I work on Daydream, and Daydream, its purpose is to create a standard platform for mobile VR. Similar to how Android created a standard platform for smartphones, it's great for developers because they can target a wide range of phones. It's great for users because they know that apps that they purchase are going to work across phones. And something that developers really care about is knowing that there's a stable hardware target for them to hit. This is very important with consoles, to know what you can test on, to have that stability. So the great thing about the Daydream program is it provides a stable set of hardware for developers to target. Everything from low persistent displays to high performance SoCs to low latency sensors. You know that every Daydream ready phone is going to have at least hardware as good as the minimum spec. And this means the developers can target a really broad range of phones. Right now, pretty much all of the major OEMs are working on Daydream ready phones. Samsung, LG, HTC, Huawei. All of the big OEMs are on board and are presently working on Daydream ready phones. Daydream also involves a standard reference design for a headset. So OEMs can design headsets for users that will work with their phones. Also, other people can create headsets as well. And every headset will include a controller. This is obviously a really big deal for developers because you know exactly what controller users are going to have in their hand as they're interacting with your app. That controller has a stable set of buttons. OEMs might be able to change the materials and finishes a little bit, but the actual interactive capabilities and the onboard hardware is always going to be exactly the same. Here's the Daydream home screen, where users can go through the various apps that you'll be creating to find what they want to try out. We'll also have all of Google Play in Daydream. So in VR, you can see various applications that you've created. You can actually have a photosphere for your app, which will be the environment around your application as users are browsing the apps that are available in VR. So that's a quick overview of Daydream. What I work on is helping our partners and people on the platform create the best possible applications in VR. And VR creates really a whole new set of design challenges. There's all sorts of mistakes you can make in VR. In many ways, it's like the beginning of mobile or very early with the web, where we see things that are great, we see things that are horrible. There's a broad range of quality. So what I want to go through in this talk is some of the things that we've learned so far, some best practices for how you can create great apps. And just to get a sense, how many people in the room are mobile developers? A few console developers? VR developers? Quite a few. Okay, so this will be hopefully lots of stuff that at least half of you are familiar with. So lots of different things to talk about. So breaking it into 4 areas, talking about the user, the interface. Obviously, if you're creating a game, the interface may be more than just something in front of you. The environment that interface lives in, and then the controller. So diving into understanding your user. For the mobile developers in the audience, this can be a bit of a challenge, but you have to kind of forget everything you know about mobile game design. Because even though this runs on a phone, the user can't see the phone. The phone isn't really part of the experience in the way that it is for mobile games. A lot of mobile game design is about very short, 90-second or less interactions, very snackable content, very transient experience for users where they're on a subway and they're waiting for their next stop, so they pull their phone out, or they're in a coffee shop and their friend leaves for a moment, so they pull their phone out. None of that is true with VR. People aren't going to be quickly putting on a headset to have a 90-second experience and taking it off. We saw that with Cardboard. That actually worked really well with Cardboard for these types of snackable moments where if you had an app like showing, say, real estate or something, you could drop it into a viewer. But once you have the controller and the head strap and something more sort of involved like Daydream, users are really sort of committing and planning to go into VR and then planning to be there for quite a while. So if anything, even though it's a phone, it's almost easier to think of it as some type of spherical projector with a tent that the user sets up in their living room. It's this place that people go. They can carry it with them, and it's just as portable as a phone. But for the experience, you should expect them to be planning to be in VR for a while. So if anything, being portable, it's sort of more like a book. It's something that you don't read a book for 90 seconds. You plan to sit down and read a book for a while. And if it's a really good book or a really good VR experience that you're crafting, users are going to be in there for a long time. And with a lot of the market research we've done, we found that users have a comfortable spot in their home that they always go to when they're in VR. Often if it's a seated experience, this will be a comfortable chair or couch. If it's a standing experience, it'll be one of their rooms. So you still create like a tennis app or something where people are standing. But they have this sort of spot that they go to. And This is important to know that they're likely going to have Wi-Fi because they're at home. They'll be able to charge. It's not the type of mobility that we see with just random interactions on smartphones. So you should expect sessions to be 30 minutes or more in length. It's not uncommon for users to watch full movies in VR. If you're only providing a 10-minute game session, you should expect the user to then launch a different game to play that for a while. Because users are really committed when they're in VR, and they're going to be there for a while. So that sort of talks about the context of the user. Let's dive into physiological comfort, which many of you, as you've used VR, you're probably familiar with. So what is it about roller coasters that make people sick? And both real and virtual roller coasters. To sort of take a very high-level view at this, imagine it's a beautiful morning, hundreds of thousands of years ago. You wake up and the sun is shining, and you go outside and you don't see any predators, so that's awesome. And you're really hungry, so it's time to start foraging for food. You find some berries, and these look delicious, but you've never had them before. And as soon as you eat them, the whole world gets kind of whooshy. And you get it's like ringing in your ears, and it's a very weird experience. This is a critical moment for you, because you either sort of expel the berries, or it's game over. And for our ancestors that did expel the berries, they survived. So we've evolved to be very sensitive to vestibular ocular disparities, differences between our movement and our vision, because of poisonous berries. And about a third of the population experiences motion sickness. For the other 2/3, you were very lucky that your ancestors survived and didn't eat any poisonous berries, because they would have been gone. So what this means for VR is, in your ear, you of course have your cochlea, and we have the inertial measurement unit in a device like a phone, and the screen in your eyes. And this system has to always remain in perfect sync. If there's any type of hiccup or lag or dropped frames, you're not just creating sort of janky experience in your game, you're actually making the user physically ill, or at least a subset of your users, a pretty big subset. So the big takeaway from this is always maintain head tracking. It's really, really important. Even if you're doing something like loading a new scene in your game, it's super common for applications to actually just freeze everything because they're busy loading the next scene. You can't freeze everything. Like you have to, if you can't track, you have to fade to black first or fade to any solid color. It's really key, because even these like little 1-second freezes are going to cause people to feel ill. Other things that are really important, you really want to keep a stable horizon line. You can make people very sort of seasick or literally fall over. If you are moving the user, it's best to teleport them around, but you want to maintain a constant velocity of movement. We don't actually feel velocity, we feel acceleration. So a good example of this is when you're on an airplane, you'll definitely feel the takeoff and landing. But when you're traveling at 500 miles per hour in the air, you're not actually feeling that. You're feeling slight turbulence and little slight changes in the velocity, but you're not feeling the velocity itself. So it helps when, in virtual reality, if you're moving at a constant velocity, there's not as much of a disparity versus if you're having lots of acceleration or deceleration in virtual reality, which of course you're not feeling in real life. All right, so that covers the user and sort of their context and the physiology. Let's talk about the interface a little bit. So VR can, from a design perspective, seem a bit overwhelming. The user can look anywhere, you could place UI anywhere, sort of an infinite screen, infinite possibilities. So how do we sort of wrap our heads around that? As designers, we're used to thinking about having a canvas or a page size or at least something to constrain it. So one sort of initial thing to think of is that the user's sort of field of view is about 70 degrees. This is about the size of an IMAX screen. And then in terms of their range of motion, they can go about 80 degrees to either side with moving their neck. You can start to move farther if you start moving your shoulders, but if you assume they're seated back in a nice, comfy chair, and of course all of these figures it's a bit of a range because everyone has different necks. But if you stay within 80 on either side, that'll be pretty good for not having them to, say, get up and move their shoulders a bit to see something. And then people tend to look about 15 degrees down. So if you're setting up your computer monitor on a desk, it's nice to have the center of that about 15 degrees for the most ergonomic view. If you're having some type of piece of UI that people are going to be looking at for long periods of time, having it just a little bit below the horizon helps. All right, so this sort of creates your canvas of both the field of view and the range of motion for where you can create your UI, assuming that you want the user to be seated. Some other things to consider is the distance of items. So interfaces, especially in VR, at the beginning you'll start to design things that are very close to the user. This can be very problematic, especially if there's things in the sort of half-meter range. If it gets within less than half a meter, you start to not be able to focus on it. Example of this, if you put your finger up in front of your nose and try to focus on your finger, it'll start to blur out at some point. So it's good to keep things beyond half a meter. And then at 20 meters, you start to lose the stereoscopic 3D of it. Especially in 3DOF, you're not going to be able to move your head side to side, so you're not going to really have a sense of 3D beyond 20 meters. Something else to consider is the importance of texture and shadows for understanding depth. If you don't have any texture and shadows, it can be very unclear. But then as soon as you add those in, you start to understand the depth of the scene. And one of the early mistakes we made was we had flat textures and everything. And once you have a flat texture, it can start to look like this sort of infinite void, or kind of a portal onto an infinite void. And when you add texture onto that, you start to have an understanding of where it exists in space. So it's important to have some amount of noise, even on something that would otherwise be flat. In terms of display resolution, so if we had 60 pixels per degree, that would be getting pretty close to 20/20 vision. Some people have better than 20/20 vision, so even at 60 pixels per degree, some people would still complain that it's not perfect. We're not quite there yet. Unfortunately, we still have to deal with lower resolution screens once we put these huge lenses on them. So things like very thin lines or very thin fonts can be problematic. Obviously, turning on anti-aliasing helps, but then that'll hurt performance, which could make people physically ill if you start dropping frames. So an important consideration of design is what font size should you be using. So one way to think about this is if you know the pixels per degree of the device, which is pretty easy to figure out, and is probably the metric we should be using for phones in the future, just talking about pixels per degree. It's a much more sort of standard way of thinking about it. So today we're around sort of 10 to 14. I think most Daydream-ready phones are in the 13 range. 60 would be perfect. If there's anything we're good at, though, it's putting more pixels into screens, so hopefully we'll get there pretty soon. But in terms of font size, the angular height of the font, you can map that out over the pixels per degree, or if you have a 1.5 degree font now, that will be readable and comfortable. And then over time, you can get down to considerably smaller, where you could have something equivalent to like your 30-inch monitor in VR, which would be great. And of course, there's a difference between comfortable and just purely readable. So this is a good way of thinking about the angular height of your font. So at 13 pixels per degree, we're looking at about 20 pixels for your font. Of course, you're not thinking about pixel height in your game engine, you're thinking about meters. So a way of considering that is calculating the height and distance off of the font this way. So pretty straightforward. You can actually simplify that down to just 0.0227 times the distance for a 13 pixels per degree height. So with this, you can calculate the best font size to use. All right, so that's sort of basic ergonomics of your UI. 70 degrees field of view, 80 on either side in terms of neck movement, and then 1.5 degrees for fonts or something that's readable. Let's consider the environment the user's in. So it's pretty common to see these sort of empty voids environments. Sometimes there's little floaty things or a grid, but generally empty voids are pretty common in VR. And I was talking to some other designers on the team, and they're saying, I have all these memories of being in VR locations. Some of them are great, some of them are really interesting. A lot of them are kind of depressing. It's just sort of like I'm in a dark room with like a spotlight on me. It's like I've been abducted by aliens or something. Like, why are we doing this? And like, there's a lot of reasons, focusing on content over the environment is important, or it's obviously performs really well. But empty voids are kind of a missed opportunity for your environment. Really, your environment it can be an expression of the brand of your application, the brand of your company. So it's important to think about, what you can do with this opportunity of the environment to actually design, something that the users really enjoy and like being there. So this brings us to the topic of, we talked about physiological comfort, also psychological comfort. There's lots of ways that the environment can actually sort of affect users psychologically. One of the things that I found most curious, it's a common mistake right at the start of designing a VR app, is you accidentally drop the user into an object collision. Now, this obviously, it doesn't hurt. Like, there's no way for the virtual table to hurt you. But it's still wrong. Like, you look down and you think, this is not right. And you kind of want to walk away from the table to stop it from happening, even though it's not doing anything to you. So there's definitely this aspect of how the environment can kind of impact your psychology. Another really memorable example for us was we dropped users into a sort of nice ocean scene for an environment test we were doing. This is one of the early concept art images. And they just immediately ripped the headset off. They were just terrified being on the floor of the ocean, which isn't something that we would immediately consider. It's not like we surrounded them with like clowns wielding chainsaws or big spiders or some more direct scary thing. But for them, it was really terrifying. So some of these can be very sort of content driven. But there's also almost like this more kind of architectural set of phobias, just things based on geometry that will make people generally scared. You, of course, have your fear of heights, very common in VR. You have claustrophobia, fear of small spaces, also very common and hard to focus on. Opposite of claustrophobia is agoraphobia, fear of large spaces, which not as common, but still exists. I actually have a bit of agoraphobia. Like, this would be the worst work environment for me in the world, like trying to focus at a desk with, empty void. So we see that show up in some of our environments that we've been testing. So like, something like this where you have this sort of hallway off to the side, there's kind of a general feeling of like some monster is going to come down that hallway at some point. So I need to sort of keep an eye on it. So you just feel slightly unnerved. So scale can be very interesting for VR. If you have things that are really small, you feel really powerful. They're very toy-like and fun to play with. And then the inverse is true. If something's really large, now suddenly it's very sort of scary and dominating. And this isn't just trucks. You could have an interface, which is really big. And as you look at that interface, you just feel small yourself. Other things, people don't like to be crushed. This is maybe an extreme example, but I was trying like a solar system educational thing, and looked over and there's a planet coming right at me. And part of my brain was saying, like, get out of the way. This is really going to hurt when that planet hits you. So you sort of can't help but feel that. Feel like an object coming at you is going to be a problem, and you can't really turn that off. So it's important in your design to think about these things. Obviously, sharp objects, a bit of an issue. Any sharp objects that are coming towards your eyes, people are going to flinch and close their eyes and duck away. So if it's a nice meditation application, you have little hummingbirds, one of them gets up towards your eye, it's going to be the opposite of meditation now pretty fast. So that's sort of things to think about in terms of the environment. For the controller, give a quick overview of that. So this is the Daydream Controller. You can use it to point, sort of a laser pointer. It's 3 degrees of freedom. You can gesture with it. It has an accelerometer there to pick up the gestured information. In terms of input, you have a clickable touchpad, so it sort of clicks in like a mouse button. Also, it's a 2D touchpad, so you can do swipe gestures on it. Then you also have an application button, which developers can use for whatever they want. And then there's a reserved home button, or system button, which will take the user back to main menu for them to select another application. So what we've been finding is there's really, even at 3DOF, there's a wide range of experiences that you can build with this controller. Anything from playing tennis, did a quick test of like real-time strategy game where you can select characters and then point to move them around. And this actually, you're pretty precise with a laser pointer. If anything, you're almost too precise. Like if you're trying to paint, like you'll start to see like a little bit of handshake in it, where it's so good that you start to find your own limitations. Here's an example of the user doing a drag rect and then drag rect with the touchpad on the controller, then bringing the characters around. You can, of course, use this for flying. This was an example where we had a kite and you sort of trying to fly the kite through various objects and collect coins. Object manipulation. This was an example of pottery. We also had one where you could sort of laser point objects and pick them up, use the touchpad to drag them towards you and move them around a scene. One of the more popular ones, flipping pancakes, which is what everyone wants to do in VR, it turns out. Works really well. If they can get them on the plate, though. Oh, no. Let's knock all those off. All right, so we've released all of these. There's 16 demos called the Daydream Controller Playground. It's up on GitHub, so you can look at all the source code. And you can build your own dev kit with Daydream right now. You can just use the Nexus 6P as the phone. And then if you just use any Android phone, you can install an emulator on it to emulate the controller. So if you want to begin development for Daydream applications, you can dive right in. All right, so that brings us through the 4 sections of the experience for users. At this point, I have a little bit of time left. I'm happy to take any questions that you have.
Can it support 2 controllers at once?
No. And there's a few reasons, but the most important is fragmentation. We want developers to know exactly what users have. We don't want users to feel like they can't install an app because they didn't buy a second controller. We're requiring 1 controller for every headset, and then we know that it's stable for everyone.
Yeah, just wondering if you're going to have a WebVR-enabled browser within Daydream, if somebody wanted to create a experience on their browser and not do the app base. If there's going to be a way to, out of the box, have fully immersive WebVR.
We don't have anything to announce right at this moment, but WebVR is something that Google's interested in.
I had a question about the kind of the environments that you guys were looking at during your testing. You talked about most of the UI was using big open spaces and kind of focusing everything in on a tight area. Was there a reason for that, or is that just kind of it was easier to develop that UI and then adding things to all the other space would be difficult?
Well, a couple reasons. One is we didn't want to require users to have to move around too much. So if you're using this, in an airplane seat or something where, even though you could, get up and kind of turn, we didn't want that to be, for something as simple as like a launcher, to be required. Another is it's a little bit overwhelming to suddenly have this. We did a test with YouTube where you had YouTube videos in a sphere around you, and everyone just kind of immediately reacted like, "Oh boy, this is really complicated." So there's kind of this like cognitive overhead of having that level of complexity. But depending on the type of experience that you want to create, there might be cases where that actually works really well. So it's not like this is a hard rule that you should always restrict down to field of view, but to think about the context of your user, both sort of physically and also mentally, and what makes sense in that situation. It's a good question. We haven't, aside from sort of Aggie notes in these types of talks, we haven't shared more broadly. Part of that is making sure that we need to scrub all the data so that there's nothing identifiable for the users, that kind of stuff. But I would like us in the future to be able to share more broadly some of the findings that we've had through all the market research and studies we've run. All right. Well, thank you.